All right, today we're going to dive into a really cool paper called CEPchain, a graphical model-driven solution for integrating complex event processing and blockchain. Now, I know that's a mouthful, but stick with me, because it tackles a huge real-world problem by combining two very powerful technologies in a seriously smart way. First things first, let's give a huge shout out to the researchers behind this work. They're from the University of Cadiz and the Vienna University of Economics and Business, and the paper was published in the journal Expert Systems with Applications. All the details are right here if you want to check it out for yourself. So, to really get why this technology is such a big deal, let's start with a journey that, honestly, most of us take for granted, but our lives often depend on it. It's the journey a vaccine takes from the lab all the way to a patient. And it is a delicate, high-stakes race against time. Yeah, this whole journey happens on what's called the cold chain. And trust me, the stakes are incredibly high. If anything goes wrong along the way, the consequences can be, well, pretty serious. A cold chain is basically what it sounds like, a supply chain that has to stay cold, continuously. For a lot of vaccines, we're talking about a super tight temperature window, usually between 2 and 8 degrees Celsius. If that chain breaks, even for just a little while, poof, the vaccine can become completely useless. So that gets us to the absolute heart of the problem these researchers tackled. When something does go wrong, how do you prove it, right? How can everyone involved, the manufacturer, the shipping company, the doctor, trust that the record of that failure is legit, that it's permanent, and that nobody's messed with it? And your first thought might be, hey, what about blockchain? I mean, it's an unchangeable, distributed ledger. It seems perfect for this, right? Well, it turns out the obvious answer isn't quite so simple, especially when you're dealing with a constant flood of real-time data. Okay, and here's where it gets really interesting, the cost. Just imagine a temperature sensor on a shipping container, sending a reading every single minute. If you tried to log every one of those on the Ethereum blockchain, whoa, the cost would just be insane. The paper shows that even the cheaper way to do it costs almost a penny for just 32 bytes of data. That adds up fast. And it's more than just money, though. The smart contracts that run on the blockchain, they're just not built for this kind of work. They don't have the tools to ask simple questions like, hey, how many times in the last hour did the temperature spike? Or what was the highest temperature we hit? They're just not designed for that kind of real-time analysis. So, if blockchain by itself is too slow and way too expensive, what do? Well, this is where the paper gets seriously smart. Instead of trying to force a square peg into a round hole, they bring in another piece of tech to do the heavy lifting. And that brings us to something called complex event processing, or CEP for short. The easiest way to think about it, it's like a super fast pattern detector. Its whole job is to just sit there and watch a massive fire hose of data, like all those temperature readings, and spot really specific patterns as they happen, in real time. And boom, that's the genius of the whole system right there. You let the CEP engine do all the hard analytical work off-chain, where it's super fast and cheap. And then you only use the blockchain for what it's amazing at, creating that rock-solid, unchangeable, trustworthy record of the really important stuff that the CEP engine finds. It's the best of both worlds. So the system they built is called CEPchain. Now, let's stop talking theory and actually walk through how this works with a real vaccine shipment. Okay, so here's a look at the architecture, and you can see that clear separation, right? Up top, you've got the off-chain world. That's where all the sensors are feeding data into the CEP engine, and it's where all the speedy analysis happens. It's only when something important is flagged that it sends a signal down to the on-chain world at the bottom, the blockchain itself. Let's really break this down. First up, you've got this constant stream of temperature data coming from the sensor. Step 2, the off-chain CEP engine is just watching, and it's been given a very specific mission. Look for more than 50 readings that are outside the safe zone within a single hour. The second that happens, bam, it detects a critical event. And step 3 is the absolute key. Only that specific temperature alert actually talks to the blockchain. All the thousands of normal readings, the chain never even sees them. And finally, step 4, that alert is locked in forever on the blockchain for everyone to see. And here is the proof in the pudding, right from their experiment. This is a look at the actual blockchain ledger. You can see the smart contract being set up, and then you see those 2 contract calls. That's it. That's the CEP engine automatically writing the temperature alert events it found to the chain, creating that permanent, undeniable evidence. So we know the system works. But the really cool part goes beyond just the tech itself. The researchers made it incredibly accessible. You could almost call it a no-code revolution for supply chain monitoring. So let's just recap the huge benefits here. It's way cheaper because you're not writing tons of data to the chain. It's super efficient because the blockchain isn't getting bogged down. But honestly, this might be the biggest win. It empowers the actual experts, the logistics managers who live and breathe the stuff, to set up the rules themselves with a simple graphical tool. No blockchain coding needed, which also means, fewer mistakes. And this just leaves us with a really big question, doesn't it? The paper is all about vaccines, but this technology could go so much further. I mean, think about it. High-end food, sensitive electronics, even the chain of custody for legal evidence. What other critical supply chains could be secured with this combination of real-time monitoring and immutable proof? And that's our look at CEPchain. It's just a fantastic, elegant solution that shows how combining the right tools, off-chain speed, and on-chain trust can solve some really complex real-world problems. A huge thank you again to the authors for this truly insightful work.